In most economic problems, someone is trying to do the best they can given their circumstances. Or, put mathematically, they're trying to optimize something subject to a constraint. There are several ways of solving such a problem mathematically, and one of them involves simply substituting the constraint into the objective function. In our case, we have someone who wants to maximize their utility subject to their budget constraint. And one way to solve such a problem is to substitute the budget constraint into the utility function, therefore turning the utility function into a function of simply one of the two goods rather than both of the goods. In this graph, we will illustrate how this mathematical formulation of the optimization problem translates into a graph. To be more precise, we can solve the budget equation for one of the goods, say x2, and then substitute that into the utility function, therefore giving us a function f of just x1, or good 1. This function is then illustrated here. It's a function that is upward sloping initially, attains a maximum, and then is downward sloping. The highest point of this function, the maximum, can then simply be solved by taking the derivative of the function and checking to see where that derivative is equal to 0, because the derivative of the function is simply the slope of the function. Thus we take the derivative of the function f, set it to 0, and solve for x1. For the utility function and the budget equation in the text, the solution to this problem gives us that x1 is equal to 5. This implies that a consumer of this type, facing this constraint, will do the best she can given her circumstances by choosing 5 units of x1 and then spending the remainder of her income on x2. For consumer utility maximization problems, we will usually employ the Lagrange method instead of substituting the budget constraint into the utility function as we've done here. However, the basic underlying intuition is exactly the same, as we will again solve first derivative equations set equal to 0. Later on, when we develop producer theory, we will return to this method, in other words, the method of substituting the constraint into the objective function, and solve some of our problems that way.